Now that we have seen the main components of the transformer and have ensembled them into code functions, including the code where we integrate them all into an encoder block, it is time to start exploring the decoder. The first thing that we have to note is that, as with the encoder, we start the decoder with an attention module. However, this attention module is a special one, and it is called a masked attention mechanism. So what does it mean? In the attention section of the course, we learned about the scale dot product attention formula. We saw that we calculate the attention scores as the dot product of Q and K. This gives a matrix of scores that represent the degree of attention each query should pay to each key. We will take the attention scores calculated above and will apply a mask matrix. To create a mask matrix, we can use the torch.true function, which will produce the needed mask. In reality, the function fills the matrix with ones and zeros, but we apply a Boolean function to transform it into true and false. This mask matrix has the same dimensions of the input sequence, that is, the number of tokens. With the attention scores and the mask matrix, we create the masked attention scores. For this, we will multiply these two matrices. The mask is then applied to these scores before the softmax step. After the mask is applied, softmax is run on these masked scores to turn them into a probability distribution. Next, after the masked attention module, we have another attention mechanism called the cross-attention module. In the self-attention mechanism that we saw in the encoder, the input came from the same encoder, and with it we created the query, the key, and the values. In the cross-attention module, the key and the value come from the output of the encoder, and the query comes from the decoder. With the cross-attention mechanism, the decoder can attend to the input of the model which was processed by the encoder. So it used the output of the encoder as a guide to understand the context of the input sequence and generate the next token within the context. The implementation of this is similar to the self-attention function that we have seen before. The only difference is that the key and the value parameters come from the encoder. After the cross-attention module, we have another feed-forward neural network, which will behave exactly as the one we already saw in the encoder. Then we will have a linear layer that maps the decoder's output to a much larger space that represents the vocabulary of the language being modeled. For example, if the model output is 512 and the vocabulary is 30,000 words, then this layer will convert that output of 512 into 30,000 words. And then we have the softmax, which will take the output of the linear layer and converts these raw scores from the linear layer into a probability distribution. This probability distribution is used to select the next word in the sequence. In training, the highest probability word is typically used as the prediction. During inference, especially in autoregressive models, a sampling strategy like greedy decoding or beam search or top K sampling are used. Also, during training, the softmax probabilities are used to calculate the loss using a loss function like cross entropy, which compares the predicted probability distribution with the actual distribution, meaning the true next word. Once the softmax has the probabilities for each one of the tokens in the model's vocabulary, we pick the next token and append it to the input of the decoder, and a loop of generation finishes. This loop is repeated until the training is finished or until the inference is finished. In the case of the inference, the loop continues until one of the following conditions is met. 1. Until the model reaches an end of sentence. 2. Until the model reaches the maximum context. Or 3. Until the model reaches the maximum size defined by the user, usually called the max tokens. As in the encoder, we also have residual connections and layer normalization in the decoder. The implementation is the same as seen before. So with this, we have finished the exploration of the transformer, layer by layer. At this point, looking at this diagram, we should be in a good position to understand each one of its components, their role, and the way they impact the results of this amazing artifact.